In this class, we will continue our discussion of bivariate regression by focusing on the elements of the bivariate regression equation. Regression is frequently represented in an equation. In bivariate regression, the equation is the old formula from geometry used to draw a straight line, or y hat equals bx plus a. Let's look at each element of this formula and see how we use it in regression statistics. Y hat is the predicted score on y for every value of x. Essentially, it connects every predicted score on y in a straight line and is then drawn through the plot of scores on x and y for all participants, as you can see in this slide. It is computed by multiplying an individual score on x by the value of b and then adding a to that product. In this set of data, y hat equals 0.3 times x plus a negative 0.85. In this circumstance, that would be our bivariate regression equation. A is called the y-intercept or the constant. By y-intercept, I mean the predicted value of y when x is 0. If you look at the equation, when x equals 0, y hat equals a. By the constant, I mean all predictions of y are increased or decreased by the value of the intercept. In this data, a equals a negative 0.85. Thus, when x equals 0, the predicted value of y equals negative 0.85. As discussed in an earlier slide, when x and y are not correlated and b is 0, then the regression line is flat. When that is the case, a will equal the mean of y. This is another way of returning to what we learned in an earlier slide, that when we have no other information from any other variables to predict y, our best predictor is the mean of y. B is called the regression coefficient. It is used to multiply or weight a person's score on x in order to best predict someone's score on y. B is also referred to as the slope of the regression line. The slope is defined as the rise over the run. Thus, if b equals 1, for every unit of vertical change in the regression line, rise, it makes the same unit increase horizontally, which is run. In the example in this slide, b equals 0.30. For every 0.3 unit of vertical increase, the line will increase 1 unit horizontally. Thus, the regression line is increasingly horizontal when b nears 0. In fact, when there is no correlation between x and y, b equals 0 and the regression line will be horizontal. Another important attribute of the regression coefficient is that it equals the change in the predicted value of y when x increases by 1 unit. In our example, the regression equation is y hat equals 0.3x plus a negative 0.85. If x equals 10, our predicted value of y equals 2.15. If x increases 1 unit and becomes 11, our predicted value of y is now equal to 2.45. Thus, as x increased by 1 unit, y increased by 0.3, or the value of b. Before going to the next slide, see if you can answer this question. If the bivariate regression equation is y hat equal to 0.80x plus 2.50, what is the predicted value of y when x equals 5 and when it increases by 1 unit to x equals 6? How should y change when x changes from 5 to 6? The answer is that when x equals 5, y hat equals negative 1.50. When x increases to 6, the new y hat is negative 2.30. Thus, as x increased 1 unit, y hat decreased by 0.8 units, the value of b. The gap between any predicted score on y and the individual's actual score on y is called a residual. It is an error in prediction. The arrows in this slide note the actual and predicted score on the criterion for an individual who scored 21 on the Beck Depression Inventory and scored 3.5 on the Suicidal Intensity Rating Measure. Using the regression equation, we predict the individual would score 0.3 times 21 minus 0.85, which is all equal to 5.45, which we could then round to 5.5. Thus, the residual associated with this participant equals 5.5 minus 3.5, or 2.0. Collectively, residuals are analyzed to determine our average or standard error. The standard error of the estimate is the average distance a predicted score on y can be expected to deviate from the actual score on y in the population. You can think of the standard error as existing in a band that runs above and below the regression line. The better the regression equation, the smaller the standard error of estimation.